Do you think it's possible for us to ever get to a place where that systematic approach to critical thinking and questioning can actually be captured in some form of algorithm, that the algorithm itself is doing the critical thinking for another algorithm?
I honestly, I'm not. So first of all, I'm not sure I'm the right person to answer that. Yeah, I mean the speed at which AI develops is sometimes almost scary. Okay,
Mhm.
so it's hard to make any predictions on like, oh, we'll never get
Yeah.
here and there. But I do think that this is a lot harder than people think.
As an educator, when the students can get instant answers from Gen AI, right? What then becomes the job?
Yeah. Look, this is a great question, and honestly, I'm not going to claim I have all the answers. Okay, but I think there's several things you have to ask yourself. Okay, so first of all, if Gen AI can do all of your homeworks, then I have to question: Are you giving the right types of?
Juergen Hahn, professor and director of the Jackson Center for Biotechnology and Interdisciplinary Studies at Rensselaer Polytechnic Institute, over 130 publications, 40 graduate students mentored, pioneer data science approaches for autism diagnosis. He mentored my research as a graduate student at Texas A&M University, and he has spent decades exploring how we use system analysis to understand everything from chemical plants to the inner workings of the human body. In our discussion, we talk about the limits of AI, what happens to education when machines and computers can answer everything, and why asking the right questions might be the only skill that matters the further we go into the automation and intelligence age.
What gets kind of masked oftentimes is that the AI models are really oftentimes similar in structures to AI models we had 30 years ago.
Yeah.
They're just much, much bigger than basically, and they were trained with much more data. But in the end, there's certain things that all of these models kind of suffer from. Okay, they're interpolating existing data.
Yeah.
That's not what critical thinking is. People still need. Yeah, I
Yep.
think one of the things that's going to happen is that the amount of programming people do that will probably change quite a bit because most generative AIs can program very well,
Yeah.
but they also program based upon what you tell it to. Yeah, and if you're not precise in formulating
Mm-hmm.
what you want it to do, you're also going to not get what you expected.
Yep.
Those are some important skill sets as well, which come down to it. Yeah, ask the right questions. I think that's all. That's an important part that I don't see going.
Before we go deep in this conversation, quick ask. If you're watching on YouTube, subscribe. If you're on a podcast app, please follow. This conversation is one of many that are shaping a book I'm writing on how we find meaning as we go deeper into the automation and intelligence era. It's called Practice Ground, and the book is coming later this year, 2026. Don't miss it. Now, back to our interview. So, Juergen, thank you for taking the time to talk to me. Um, you know, our journey, will I say, started together in 2007, actually, when I came to Texas A&M. I was, sometimes when I look back, I was like, I was so young, and I came, I came to your lab.
Here,
Yeah. And I came to your lab then. It was a very interesting story. I don't know if you know the story. So when I applied to Texas A&M, I came from Chicago, right? So then in undergrad, I was doing a lot of like research around renewable energy and all that kind of stuff, right? And I remember coming I left Chicago thinking, let me just apply to schools that were good in chemical engineering. That was the main thing. So I remember I applied, and then I came to the department, which was January 2007. And I think I was like, so where's the renewable energy in kind of like division? Who was working on renewable energy? And I remember the lady at the place was like, I don't think you look at the brochure. We don't really have renewable energy. But she was like, go talk to, I think it was Professor Hawagi then. And he was like, okay, he does process safety optimization. I spoke to him, and then he directed me to you. And then we had this conversation. You were like, hey, think about it. This, you're optimizing processes, you're making it more efficient. It's not necessarily, renewable, but you could look at it as a way to optimize. And that's literally how I got on this path through the work that you've done. And then I ended up from there going to Rockwell Automation, learning about model predictive control, and just literally getting into this world where now we're at a phase where it seems like this is all everybody's talking about, generative AI and all that kind of stuff. So thank you for taking the time. Um the reason I reached out is I'm writing my fifth book, and it's around how to find meaning um, as things get more automated, as we go into the automation age. And there's a lot of uncertainty out there for a lot of people that feel like, um, what does life look like when, we have so much automation? So I'm trying to talk to as many experts that have been in the field for such a long time to, in my opinion, try to tell people to relax if they can. And, for you, your journey, you've mentored and been a professor to more than 40 students, released about, I think, 128 publications, at least that I see online. Um, you moved to RPI in 2012, I believe,
That's right.
and from Texas A&M, became the head of the biomedical engineering department in 2013. And I see you're the longest serving head so far, 12 years. And now you're the director for Center for Biotechnical and Interdisciplinary Studies. So, I think one question I have is, when for you, you've gone through this and you do a lot of research around developing techniques for system analysis, and then using those techniques either for biological systems or chemical systems. When you're debugging a complex system, what does your kind of intuition tell you that you don't necessarily see within the data itself? Like, how do you bring your, intuitive knowledge to the process?
Yeah. I mean, look, intuition is a really important part. Okay. Like oftentimes there are things they are in the data, but they're not so obvious that they jump out at you. And that's
Mm-hmm.
then where your intuition comes, and you're saying, well, you know what? This part here in your data, this could mean many, many different things, right? It could be one interpretation which makes a lot of sense, but it could also be like, oh my God, we don't really understand what's happening here, and we need to dig deeper into this.
Mm-hmm. Mm-hmm.
In particular, when you're supervising students, yeah,
Yeah.
they come to you and they have some data and they have an interpretation of the data, and then it's your job as a professor to go back and saying, well, that's one interpretation, but let's make sure it's the real one
Yeah.
because we don't know yet. All right. And so then you have to kind of, I mean, intuition has a lot to do with your past experiences, right?
Mhm, mhm,
And also looking at the bigger picture. Okay, because like if I use an algorithm to find something, yeah, the algorithm can find trends that I may not be seeing, but the algorithm doesn't really usually know anything about like the physics or the biology of a project, or I mean, or a business model if you're
mhm.
business models, which we don't do in my group, yeah.
Yep.
But this is basically the algorithm doesn't know about that, yeah. And so your experience then comes in and says, well, yeah, that data could mean many, many different things. And
Mhm.
why don't we say, like, let's narrow this down, okay?
Yeah.
Like, let's change some of your conditions. Let's recollect some of the data, because if I think that your hypothesis is that what you're seeing is because of X, then if you make this change, this and this should happen. If it doesn't,
Mhm.
then it's
Yep.
probably not because of X. There's probably something else going on, which means we need to dig deep. Okay,
Yeah, yeah.
always honestly, there's no data sets ever complete where you say, oh, yeah, I have everything I need.
Exactly.
Doesn't happen. And so you always have to you have to start with a reasonable collection of data to see where do you think this journey of analyzing the data is going to go. but then you really also have to rely on your intuition saying, well,
Yep.
let's modify, let's change our experiments or our simulations a little bit, see
Yep.
what happens as a result of that. And then basically see if that certain assumptions that you made will hold up.
Yeah,
Yeah,
exactly. And
and that's a really critical part. And I would argue now, admittedly, I come from this very much from the academic side, right, where
mhm,
educating students is important. But that's a really important part of the learning experience that as a student you go through this and saying, okay, well, I thought it is this, but you're right. There may be other reasons. Let's more critically think about this because
got it.
that's a skill set that it's you can't exactly teach. You can just
Mhm.
prod and push people in that direction, but developing that skill set, there's not like a clear guidebook on how do you do.
Yeah. And
And
yeah, I wanted to ask you about that. What I'm hearing a lot is like critical thinking and training people about this experience. And, when I was at Rockwell, one thing that I learned was, we'll go to these factories and we'll do like all these regression models and we'll, install it to work on their, distillation column and all that kind of stuff, right? And we'll be looking at the graphs and everything is going well. And then we'll see like a spike in something, the temperature or something, right? And I'm using a random example here. And we'll be sitting behind the computer trying to figure out like what is happening, what is going on. And then the operator that has just been working there for 10 years or something will just walk in and say, oh, it's spring and, the birds kind of fly across and they usually land on this thing that affects this sensor. And then they go out there and then they fix it. And that's something we didn't put in our model. We never put a model that would describe, when it's duck season and the ducks are
yeah,
flying. You know?
of course not. I mean, there's a saying that all models are wrong, but some models are useful.
Yeah, yeah,
And it's
exactly.
exactly there's certain factors that you can never ever put in your model, and so you just
Mhm.
that will. I mean, that's not going to go away. Okay, and
Yeah,
have
yeah.
this discussion in 50 years if you're still alive, we're still
Mhm.
going to find that our models will never be perfect, and
Yep.
there you just have to say at some point this is good enough,
Mhm.
and you're right, and don't discount the experience. Okay,
Yeah.
there's somebody who has decades of experience with the process. They have knowledge that you can never capture in a model,
Mhm.
because that data doesn't exist in a form you can capture.
Yeah.
Yeah.
Do you think it's possible for us to ever get to a place where that systematic approach to critical thinking and questioning can actually be captured in some form of algorithm, that the algorithm itself is doing the critical thinking for another algorithm? Is that even, can we ever
Um,
get to that place?
I honestly, I'm not. So first of all, I'm not sure I'm the right person to answer that. Yeah. I mean, the speed at which AI develops is sometimes almost scary. Okay,
Mhm.
so it's hard to make any predictions on like, oh, we'll never get here
Yeah.
and there. But I do think that this is a lot harder than people think.
Mhm.
Okay, because I mean, look, what gets kind of masked oftentimes is that I mean, the AI models are really oftentimes similar in structures to AI models we had 30 years ago.
Yeah.
They're just much, much bigger,
Yep.
and then basically, and they were trained with much more data, and this is where a lot of this comes from. But in the end, there's certain things that all of these models kind of suffer from. Okay, and
Mhm.
one item is that they're interpolating existing data.
Yep.
That's not what critical thinking is. Okay, this is internal. I mean, they have so massive amounts of data that yes, they may be interpolating data from different fields, and that may actually add new value.
Mhm.
Um, but that's different from having a completely a new idea, something that's out of the box, and testing that.
Yep.
And so I don't know. I mean,
Yeah.
we may not get there eventually, but I think just making the AI a little bigger than it is not going to get us.
It's not, yeah.
You're
And
going to
you
need some other things in there.
mhm.
I mean, likewise, to give a different example, like these models are, even though they have massive amount of data, but since they're interpolating, yeah, you end up with interpolation of results. And this is where some of
Mhm.
hallucinations come from, because it interpolates one piece of data that's correct and another piece of data and squishes them together and saying, yeah, that makes a good interpolation. But if my goal is to find a reference, I don't want to find the authors of one paper and the title from another paper because it's
Mhm. Yep.
interpolation. Yeah.
Yep.
And so that requires then a different process where you may pull some information from a data bank for that part rather than just interpolating between existing data. Yeah.
Mhm. Yeah.
When it
Yeah.
comes to critical problem solving, I think you may need a totally different piece on how to go about this.
Mhm. How do you like, or what advice do you give your students in terms of, you know, critical thinking? I remember working together, and back in those times we're using, I don't know if you're still using this, but I was using like MATLAB and Aspen to do like, some small 2x2 relative gain analysis of a controller. And I'll bring my results to you, and then you'd be like, oh, Nefemi, have you thought about this, or have you thought about this? How do you um train students to think
Mhm.
critically?
Yeah, it's by, I am honestly, that process hasn't changed so much. I mean, the proceeds, obviously, some of the tools have changed. I mean, we still use MATLAB, but then there's a lot of Python. Yeah,
Yep.
particularly
Example.
anything that's data driven, Python is just the tool of choice. Yeah,
Mm-hmm.
but Python is free, and so a lot of people use it quite extensively. But but when it comes to really like looking at your data and trying to figure out what's going on, we still go through these brainstorming sessions. Okay,
Uh-huh.
where they're saying, you give me your data and you tell me what you think happened, and I'm gonna ask some questions on, well, what would you think if this and this happened instead? Would that also be possible with your data? What other explanations can you have? And the last thing that's really important, the items like, talk to, if you have access to them, talk to the experts in the field who've
Mhm.
generated the data. That's like the issue with your bird migration that you,
Yep.
this is the issue that you and I discussing this in our lab would never even have thought about.
Yep.
Okay, this would have never been on my radar. Yeah, but suddenly you talk to somebody who collects the data, and they tell you, "Oh yeah, there's other things that have happened."
Mm-hmm. Mm-hmm. Yeah.
And I've had look, I've had cases. Um, let's give you one example. Yeah, from more recent work. But we've had cases where we analyzed data. Now this was now for a potential autism diagnosis using data science, and we found that there's a trend. One piece of the data looked different than the rest. Yeah, and then
Mm-hmm.
when we basically talked to the experts, it told us, oh yeah, that was because it was analyzed on a different day, and I guess somebody else came in and took that measurement. So now our algorithm had picked up on who took the measurement, which is obviously not exactly what you wanted, right? The
Yeah.
goal
Yep. Yep.
was to find something where there's differences in the biology, not on who took the measurements. Yeah,
Mm-hmm.
and and that we would have never known that unless we really talked to somebody who was involved in, yeah,
In the
actually
process.
creating the data in the first place. Yeah,
Yeah. Yeah.
that's something I think that's never going to go away. Okay, you
Mm-hmm.
domain knowledge, and you need to critically question what you're getting, because nobody wants garbage in, garbage out,
Yeah.
right?
Yeah.
That's, we want to make the most meaningful conclusions that we can with the data that we have.
Yeah. So Jürgen, one thing is, I see a lot of, the scientific approach. I've learned from you, grad students. My siblings also have PhDs, and we're constantly in the house just asking questions, challenging. Where did you get that data from? All that kind of stuff. So there's a big part of like, I know this process, there's a curiosity and some form of skepticism, right? When you hear something, you're like, huh? There's always a asking. My, for you, when do you, or what role does kind of getting lost in the playful aspect of like asking questions and brainstorming, and when do you switch to the mode of, okay, we're done with the questions, we just need to keep moving forward and finding the data? How do you kind of balance the two?
That's a great question. Okay. Look, let me start off. There isn't a clear cut answer, right?
Mm-hmm.
It depends upon the project that you work on. It also, I would argue that for supervising students, it depends a bit on the student. Yeah, because we have some people who love to brainstorm
Yeah.
forever, and that's a good trade, but you just have to know when to stop, right?
Mm-hmm.
And so basically, every data analysis you look at has to involve some brainstorm, okay? And but you have to ask what alternatives are there for this. You have to maybe collect some additional data to check some of these. I do think it's important to talk to other people about it, which is always why I told my students in my lab, talk to each other, okay?
Yep.
Coming at things from a certain angle. And it's also important you have people come at this from another angle and to think about it. Okay. When you get some feedback there, and you get to a point where you're saying, look, I think we've gotten to a point where we're reasonably sure that what we're having here is probably yeah, it's probably explains what we're seeing, and then it's time
Mm-hmm.
to move forward. Okay,
Mm-hmm.
because if you question everything forever, you never
Yeah.
write up your results, and ultimately people want you to get some results. But you have to have a good mix on in the process, and part of it is some processes are simpler. Like for example, when it comes to chemical plant data, build the chemical plant. Now, are there factors in there that we never considered? Yes,
Yep.
but it's a limited number. Yeah, but when
Mm-hmm.
it comes to like anything related to human health, well, I mean, we evolved in a
Yep.
certain way because of what Mother Nature thought is important.
Mm-hmm.
There's
Mm-hmm.
lots of things we don't understand. Yeah, and then on top of that, you have everybody's lifestyle that's totally different that affects.
Yeah. Yeah.
And so there's a lot more questions that you need to ask there. Yeah, so it
Okay.
depends a bit on what are you dealing with. Yeah.
Yeah. Yeah. Yeah.
Because like the less you know, the more brainstorming you need,
You need. Yeah.
which
Mm-hmm.
oftentimes also then means that maybe the models that you're trying to use should be simpler because if my understanding is this limited and my
Mm-hmm.
uncertainties are yet huge,
Yep.
then I shouldn't pretend to have understanding just because I can fit the data, right? When you
Yeah.
do that, you end up with overfitting, right? And the
Mm-hmm.
next time you apply the data in your setting, it won't work. And then people question, what did you do in general?
Yeah. Yeah.
One other thing I wanted to briefly, and that this may be a bit of a sidetrack, but I wanted
Mm-hmm.
to briefly bring this up. So, like for example, when I'm looking for new students for my research group, yeah, this idea, are people curious about what like the scientific process? Yeah,
Yeah.
are they willing to? Do they really enjoy manipulating the data, digging into this thought process? That's actually one of the most important factors I look for. Yeah, like I don't care what skill sets people bring in. Like some people know how to program, and that's good, but if they don't, that's fine too. But this intellectual curiosity, yeah, of how to
Mm-hmm.
analyze your problem, how do you go about making arguments? That is a skill set that to me is much more important than basically having skills in a particular language or having taken a particular class here and there.
Yeah.
Because you always learn a language. Yeah,
Yeah. 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 Yeah.
some people are much more interested in it than others, and that's
Mm-hmm.
really one of the key factors where I say, oh yeah, that person is really going to work out well for.
Yep. Yep. And do you think it's something that is natural, can be trained? Because I think for me, growing up, I was curious, right? But when I got into like school, I got into a phase of just, man, I just need to like finish. I just need to pass this test. I just need to graduate. And I remember even, when I was working with you and I'm like, okay, I think I've gone somewhere and you're like, oh, never mind, this is nice. Okay, go back and, find out this. I'm like, oh man, another question, right? And, but over time, I learned this process of, oh, the curiosity and the question is actually the interesting part. But it took a while for me to get there. Even when I got to Rockwell, like being around all of these engineers, there was always this intrigue of, um, oh, it's not working. Let's figure out why it's not working. But when I was younger, I was more on the side, like, can we get to the answer quick? Right. And but I've learned more of nurturing this curious side. Do you think there's a people are naturally curious, or is something that can actually be nurtured?
Well, I mean, first of all, I think everybody's naturally curious. I mean, some
Mm-hmm.
people more than others, but I think a lot of it also comes down to is that, yeah, I mean, what's been the path in your life, right? Have you been challenged to ask these types of
Yeah.
questions, or have you just accepted that here's an answer, don't challenge it, right? Um, and I understand what you're describing is exactly oftentimes in the school setting, right? This is where we have to be careful as educators. I mean, we want people to learn things, but we shouldn't basically drive the curiosity out of them because
Mhm.
sometimes it's exactly this. You have a huge amount of workload and you just want to finish this
You just
homework,
yeah.
finish the test, and you get an A on this test and be done with it. But what we really want is that you focus on let's learn this material because you're interested in it. Okay?
Mhm.
And let's learn how to ask the right questions.
Yep.
Yeah,
Yep.
and that's what I really like about working with graduate students because in graduate student school it's like, look, you got your undergrad degree, you got a GPA. Nobody really cares that much what your GPA is in grad school, but let's
Mhm.
become what I may call like professional problem solvers.
Yep.
Okay, and that's really more what the graduate school is about. And then ultimately your research project kind of just both does the training, but also yeah, because you're working on an open-ended problem where it's not
Mhm.
clear what the answer is, but also it serves as the validation when you completed a project and now you've written this up and be it your thesis or be it the paper, but you're presenting this to others and saying, "Look, I have gone through this thought process and this is
Yep.
how I ended up, and so clearly I have the skill set to solve these open-ended problems."
Yep.
I do think it can be. I mean, it can certainly be learned. I mean, if it couldn't be learned, then I'm not sure what I would be doing with graduate. And, but I mean, you find obviously some people have thought about this a lot more throughout their life, and others
Mhm.
have been more about like, well, let's deal with the more immediate problems first.
Yeah. Yeah.
I
Yeah.
think everybody has a certain curiosity.
Curiosity.
There's a lot. I mean, there's a lot you can do with the right training. Yeah.
Mhm. Yeah. How d when did you get, with your curiosity, when did you get a sense of, you know, this is what I want to work on, right? I remember, those times in the lab, I was working on, a small distillation column, which, was like a very chemical process. Jackie to my left, right? Jackie was to my left. He was just doing systems biology. And I used to think like, man, what Jackie and Jorgen are doing is so complex, right? That was how it was in my head. I was just like, what you guys are working on is so complex. And obviously I've, followed your journey and you've gone more towards the systems biology. When did you have a sense of, is it all the same for you, or did you say, okay, I want to go more towards, biomedical stuff because it's more complex, or how did that happen?
Yeah, it's so I mean there are several things that happen and they didn't all happen at once.
Mm-hmm.
And to be honest, some of it is also called pure luck. Okay,
Yes.
it's not like you set out and say, "Oh, over the next 20 years, this is what we're going to do, and this is how my career has goes." You have to sometimes go with the flow a bit.
Mm-hmm.
Okay? And you're gonna revise your decision because what your decision of what you thought is important now may be different from what you thought it was 5 years ago. It doesn't make it wrong what you did. It's just that at the time that's what it seemed like. But sometimes the environments change, things like
Mm-hmm.
that. So going back more specifically to the question, I mean, so first of all, the what I really like about the systems approach and the systems thinking that I mean, you can describe many, many different things in systems form, right? I
Yeah.
mean, I can talk about distillation columns,
Yeah.
the plants. I can talk about individual cells, or I can talk about organs or even human body and look
Mm-hmm.
to some level of systems thinking, depending on what level of abstraction you use. Yeah. So that's the first thing. What really got me interested in systems biology was that the levels of uncertainty that you're dealing with are much, much bigger. Yeah, I mean, basically, look, if you build a chemical plant, you build it to a certain spec. Okay, you
Yep.
know it's going to work somehow, and yeah, maybe it's going to work a little better or a little worse than you thought. But we have good models, we have reasonable understanding,
Mm-hmm.
and so you're building something because our level of understanding is pretty high. When it comes to the systems biology part, now I have the cell, and it does so many different things I don't even understand.
Yeah.
Yeah, and you're trying to figure out what's happening in there, and that raises that basically the level of complexity of trying to understand an existing system versus build a system that you understand pretty well is very,
Mm-hmm.
and so that's a very different type of challenge.
Yep. Yep.
And now there were some other issues that came into play. I mean, the systems biology you have, I mean, that let's say the level of impact that you have, at least in the long run, is is um, is likely a lot easier to understand.
Uh-huh.
I mean, we've
Uh-huh.
been building chemical plants and we can build them a little better, but when it comes to like, could we come up with a completely new medical treatment for something that's untreatable right now? That could be like a game changer, and it can
Yeah.
have a game changer on people's quality of life.
Yep.
Yeah, and so which that led me actually that led me to a second pivot in my career now after I was at RPI. Yeah, and so like I mean we still use the same algorithms that we used for systems biology, but we mainly about 10 years ago we mainly switched all of our applications to autism, whereas before it was,
Mhm.
I mean, we looked a lot at cytokine signaling, inflammation, and those are
Yeah.
important problems, and they're also important problems in autism. Yeah, but what really made changed my mind there was it was the second paper that we published on autism. And it was
Mhm.
basically looking at the data science approach where we took blood from, or at least a collaborator had blood samples from people that analyzed what metabolites in the blood. And we
Mhm.
our algorithm to figuring out, do the blood samples from the children who have autism diagnosis, are there different patterns in these metabolites from the ones who don't have our
Yep.
diagnosis?
Yep.
The algorithm could distinguish this pretty well. And we published this, and suddenly all hell broke loose. Like my phone kept ringing off the hook. People wanted interviews, newspapers were writing
Yeah.
about it. I thought it was good work. I did not think that it was. Yeah, and so at that point, I only had one student working on autism, and everybody else was working on other things. And so I
Mm.
went back to my group and said, you know what? Okay, it's nice to write a paper on something and get good reviews, but if there's so much interest in this field, yeah, for the work we're doing,
Yeah. Can you
should
do more?
shift our efforts into a field because literally many of the papers we write, people get excited about because they're basically uh, that type of work may not have been done before.
Mhm. Mhm.
Impact. And so for the last decade, we've really used all these data science approaches that we've developed, and we've used them extensively on data related to autism in part because it's a problem that's still very poorly understood. I mean, if you
Yeah.
about where does it come from? Well, we don't really know. Okay, we know some risk factors, but there's no definite answer there. Is that the
Mhm.
same? I mean, there's no. I mean, it's not like there's a treatment that would help everybody, but there are things you can do that help individual people
Yeah.
and improves their quality of life
Yeah.
tremendously. And oftentimes you find that when it comes to the availability of data for that type of problem, and secondly, how do you go about analyzing this? There's not that much work done. Now,
Mhm.
exactly fits into this, and that we have very complex data on what's happening, and we're trying to make sense out of it.
Yeah.
And so it's very impact driven on
Mhm.
what we're focusing on, because ultimately, I mean, look at the yes, you can as a researcher at the university, it's easy to focus on you get the next student, and as long as the student gets a good job, I think you've done
Yeah.
something.
Yeah. Good. You've done your job.
Yeah, and you've written some papers to show that, and that's fine. But if ultimately your work really changes people's lives, yeah, they say, okay, that you've made your broader contributions to society that go beyond
Mhm.
your own group, and
Yeah. 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 Yeah.
do.
Yeah. And Jürgen, like this is very interesting because as someone that is as an entrepreneur, right? On my side, there's okay, you go through several journeys where, oh, you want to solve this interesting problem, or, there's the engineering side where you're just, tinkering on stuff because you enjoy it. But then you put stuff out there and realize, oh, nobody really wants this thing I built. I thought it was cool, but nobody wants it. Okay. But then with time, as you go, then you start realizing, okay, there's market demand for something, right? And you can build something that will actually help people or create some value. And as you're saying, telling the story, is almost like just boiling it down to very simplistic. Almost there was something in the general public that responded to this research, where then it made it more clear that your research can actually have this external impact in the world, right? It was it a combination? You just said it was a combination of different things. What were some of the most crucial things? Is it more there's just more data now, or there was something culturally where people are now focusing on this topic? What were some of the main things that came around with this, will I say, impact formation for you?
I mean, well, there's multiple different things coming together. Okay, I mean, why now in this, like, we're talking my pivot from
Mm-hmm.
more general systems to
Yeah.
autism, really,
Yeah.
right? So, I mean, look, I mean, one thing that certainly played a role was that people had been working in this field, but the data science had not really made an impact in the field.
Mm-hmm.
Okay, it's like, whereas for other conditions, um, there had been a lot more work on data science. It's like, like, to give you an example, like, there were studies where the people looked at a lot of measurements, but then they compare one measurement at a time. Yeah, what we call univariate analysis. Yeah, and
Mm-hmm.
I mean, there's nothing wrong with that. But in data science, we can also say, well, if I look at multiple measurements,
Yep.
maybe I find patterns.
Yep.
Yeah, like, my first measurement may be a little too big, but not so that I would worry about it. And the second one may be a little too big, and the third one is a little too low, and each one individually don't matter, but I will look at all three of them together and say, oh my God, this is a unique signature that you wouldn't find otherwise.
Yep.
And I mean, we have all these algorithms for this. Yeah. And so then why not apply them in the field?
Mm-hmm.
So,
Mm-hmm.
so that was one item. I mean, another thing is, and this is a totally different angle, but I mean, there was some personal motivation as well, right?
Mm-hmm.
So basically, there was some personal motivation where, when I started looking at what's the state of research in this field and what is our understanding, then you suddenly found out that, well, there's more and more kids getting diagnosed, and many of them have very, very strong needs, yeah, support needs. But at the
Yep.
same time, when it comes to, like, us really understanding what's going on there and how can we meet those needs, it was clear that there's a lot more work that needs to be done, and
Mm-hmm.
that's not just by us. Okay, work that
Mm-hmm.
can really last for decades, and so all of that played a role.
Yeah. 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 Yeah.
And let me give you now basically going back 20 something years. Yeah, well,
Mm-hmm.
that's better. So what you described when you said, like, oh, you can do this work and it's great work, but nobody cares. That exactly describes the first proposal I ever submitted as a professor. Okay.
Okay.
It's beautifully written. I had a great literature review. I knew I could do the work. In fact, we did the work afterwards, even though the proposal didn't get funded. Yeah. But when we submitted it, the answers were like, yeah, who cares?
Yeah.
And it was very clear that we would never get this funded. Yeah, so we did the work without funding, and we had some startup left, and we published the work, and the papers were there. But it was really like, when it comes to, okay, well, the bigger impact, what does society think about that?
Mm-hmm.
That wasn't the case. And so for me, that was part of the learning process. Like, okay, it isn't just about doing cool work, and
Yep.
it's actually, you have to have impact on others with your work. Yeah.
Yeah. Yeah. Yeah. Yeah. Yeah.
And so,
And y-
so I mean, so I learned that lesson early on, but then you reevaluate every few years in your career, saying, like, okay, I've done a certain amount of things here. I can keep on doing what I'm doing and write a few more papers, or I need to pivot to something where I think the impact will be great.
Yep.
So, so if I so looking back at my career so far, yeah, and please understand, I'm in my mid-50s. I still have a few years left in my
Yeah,
career.
yeah, yeah. Some good
Not
time to go.
everything in retrospective. Yeah, but basically, I mean, I started out as a data scientist who mainly looked at chemical processes. Yeah,
Mhm,
the systems biology came relatively early on, but for a long time I had a pretty good balance in my group.
yep,
And then it shifted more towards systems biology as time went by. Yeah,
mhm,
and but then my systems at the time I also looked at systems biology both for bioproduction processes as well as healthcare. It wasn't just all human health. And then it moved more and more towards to the human health side of things.
mhm,
And then again for a little under the last decade, basically on the human health side, we focused on almost exclusively on autism, and that's really where I have my network of collaborators where I get data from.
mhm.
It's
Yep,
oftentimes driven by, okay, well, I can do more work in the field I'm at, and I can write papers and see where I go with this, but
mhm.
is this really where I think I have the biggest impact? And if not, then maybe it's time to think about to pivot a bit.
Yeah, yeah, yeah.
Talk to some people who claim that you usually go through these pivots every 7 years. Um, that's pretty close to what happened in my case, but I don't know if that's a theory or that was just somebody
Nice. Yeah,
thought.
yeah.
Okay, but that actually describes my career pretty well so far. We'll see.
Yeah. So Jürgen, like, as you go through and navigate, research and all these different topics, right? How do you get to points where, if I say, the meaning of what you're doing starts to get blurry, and how do you kind of anchor yourself to, okay, get back to the basics of why this is important? Do you have any practices for that?
Oh, okay. I mean, there's no really good answer other than keeping yourself on a certain schedule. Yeah, and that
Mm-hmm.
schedule needs to include, you need reality checks by talking to others. Okay, this is basically, especially talking to domain experts. Because if I'm just sitting there by myself, it's very easy to get lost. And to at some point, you think this is like you have it perfectly figured out, but the minute
Mm-hmm.
you talk to others, it becomes clear that no, I don't. And it's good that you have this discussion. Yeah, and that starts with that you and your students discuss it, that you discuss things with your collaborators. Yeah, I mean that's easy because they're next door or so, right?
Mm-hmm.
But then when you talk to people who collect the data, who may have no clue at all what you do for the analysis, and you talk to them what the problems are, and then suddenly you realize that, okay, well, what we thought is important here, that's not important at all. Okay.
Mm-hmm.
And so the best thing is you have to ground yourself and have regular meetings with people who have, especially people with different mindsets.
Yeah.
Okay, that's you need people who work where their everyday lives look different from mine. Yeah,
Mm-hmm.
because if otherwise you get that with this group mentality where we all agree to that everything is solved until you talk to somebody who basically whose daily life looks very different, who says, no, that's
Mm-hmm.
not what I'm seeing in my work. Okay, and that's like
Mm-hmm.
for us, for example, when I talk to a practitioner who um who collects the data, you end up with very different problems. Like, let me give you some examples. Yeah, like for some of our autism diagnosis, yeah, I mean, we're looking at these patterns, we're looking at everything from an algorithmic point of view, and we just say, like, well, the data, they take these measurements, they have a professional lab measure, it should all be good. Um, you talk to a practitioner, and they suddenly tell you, oh, it matters how you draw the blood, and
Yeah.
because some of the things that we're measuring, if we freeze it 2 hours later, you end up with different measurements than if you freeze it immediately. Yeah, and said, well, that it wasn't even on our radar. And
Mm-hmm.
I asked people like, well, is there a general protocol? And said, well, every doctor does this different. So suddenly you start thinking about, well, if something works well in the lab where everybody follows the exact same procedure,
Yeah.
that doesn't mean that this will work if every doctor can send you a sample and
Mm-hmm.
they may be interested in. So suddenly you start thinking about problems that were never on our radar because it's
Mhm.
very easy to overanalyze this data and start to pull some really minor things out of there, while at the same time completely lose track of important things that other people who really have the feet on the ground tell you, like,
Yeah.
"Look, you're the problem you're not solving is not." It happens to all of us. And
Yep.
and I said, I mean, the best thing you can do is just make sure you have these regular exchanges with other
Mhm.
people, and then, you have to do some honest self-reflection.
Yeah, exactly.
You start with everything that, "Yeah, I have it all figured out, and I don't need to learn from others." Well, you're not gonna get anywhere.
Yep.
It's okay to say, "You know what? This was 2 weeks that I just wasted.
Yep.
I because I didn't think about this, long enough." And that's okay.
Yeah.
Yeah, I
Yep.
mean, just don't waste 2 weeks all the time, but
Yeah, exactly.
yeah, but it's better to waste 2 weeks rather than saying, "Oh, we wasted 6 months because we didn't get out of
Mhm.
this, our mode of
Mhm.
thinking."
Yeah, yeah. And it's so funny as you're saying this, there's so many analogies that between researchers and even entrepreneurs that um I personally think researchers will be good entrepreneurs because there's just this constant trying to learn from what you've done, and reiterating and kind of driving this process. But I have a very different question. As you continue to be an educator, right? For whether it's people that are coming into the field, grad students, and we have generative AI where people is really changing how people think about school, right? Especially, you have students that can easily just get some a model to do their homework, right? So okay, now we start questioning, what does homework look like? Should we even be given homework, right? But you know, as an educator, when a student can get instant answers from Gen AI, right? What then becomes the job of the educator?
Yeah. Look, this is a great question, and honestly, I'm not gonna claim I have all the answers, okay?
Yep.
But I think there's several things you have to ask yourself, okay? So first of all, if Gen AI can do all of your homeworks, then I have to question, are you giving the right types of homeworks? Okay, and this is because there are homeworks that were perfectly fine to give 5 years ago, but right now, if Gen AI can solve the whole thing, then maybe this isn't maybe that's not a
Yep.
good question, okay? So I can tell you one thing that, we've been thinking a lot here at RPI is about, well, how can we, integrate what you can do with Gen AI rather than we're not here to police people, right?
Mm-hmm.
Because there will be things that in the future that AI will do for you that you may never need to learn about.
Yep.
Okay, but that doesn't mean you don't need to learn anything. Okay, that just means it's a question of what do you need to learn. It's a bit like, I mean, we're using calculators, right,
Yep.
or spreadsheets or whatever, computers, right, for solving many problems. So nobody would figure out a complicated way to take a route by hand anymore nowadays,
Mm-hmm.
right? That's when I have it. And so there will be skill sets that where it's more becomes important to use Gen AI rather than basically having needing that knowledge yourself.
Yeah.
Okay,
Yep.
but being able to find it is important.
Mm-hmm.
Like one thing that at least I find, yeah, I mean, with Gen AI to some degree, it's what you get out of it is also a lot of what you put into it.
Exactly. Your
You don't
prompts
know,
and
if you
everything.
don't know, if you cannot ask the question precisely,
Yeah.
you're going to get an answer that may be all over the place, and then it comes up. It's your job to not just say, "Well, the computer told me this is the
Yeah.
answer," but saying that, "Okay, you know what? That doesn't sound right. Okay,
Yeah.
maybe it gave me an answer to the wrong question, right?" And
Mm-hmm.
you have to basically saying, "How do I more precisely answer the answers?" Okay, and how do I make use of all of this?
Mm-hmm.
I think that's more that's a skill set that we're gonna have to learn is on both how to properly use AI as well as how to properly debug what it tells you, because it's a bit like
Yeah.
the data question you asked earlier. Yeah, you have to just because you got an answer doesn't mean that that's the right answer. It
Yep.
may be a right answer, but maybe your question wasn't the right one. Maybe
Mhm.
there are other answers possible, and then that's where that's a skill set that I think people still need. But
Yep.
it's clearly I mean, the emergence of generative AI will have a big impact on education and what we
Mhm.
teach people.
Mhm.
Um, I don't think anybody's figured that out how to
Yeah.
deal with it, as a lot of people trying different approaches.
Mhm. Yeah. And for me, the thing that keeps coming back is, I feel like we're in a phase where, depending on what you're watching, everything's so noisy. Everybody is an expert, right? Everybody's an expert at something. And experts always have answers. They always have answers, right? Where for me, I think the beauty, or perhaps is even learning some of the research approaches, is not necessarily about having the best answer, but having the best question, or a better question, is even the more important thing. And it will be interesting to see how education now goes around, or is shaped more around getting people to ask better questions, as opposed to
Right.
making sure they're showing up with the best answer.
No, I completely agree. Okay, like this is asking the right questions is not easy,
Mm-hmm.
and that's a skill set by itself. And part of that also is that when you ask a question, it needs to be precise, but you also need to kind of know the boundary of what you're asking.
Yeah.
Boundary, because like I mean, there isn't like one question for life in the universe and everything, right?
Yeah. Yeah.
That's not a very precise question, and you can't get a good answer for that anyway. Yeah, and so whenever you ask a question, it needs to be precise enough, but you also need to know what the boundary is of what you're defining, and
Mm-hmm.
then basically when you get the answer, you have to revisit if the question you asked is the right one or if it needs to be refined, things like this. And I think those are all skill sets where that people still need. Yeah, I
Yep.
think one of the things that's going to happen is that the amount of programming people do that will probably change very quite a bit because most generative AIs can program very well,
Yeah.
but they also program based upon what you tell it to. Yeah, and if you're not precise in formulating
Mm-hmm.
what you want it to do, you're also going to not get what you expected. Yeah.
Yeah. Yeah. Yep.
Those are some important skill sets as well, which come down to it. Yeah, ask the right questions,
Mm-hmm.
and,
Mm-hmm.
and I think that's an important part that I don't see going away.
Yeah. Yeah. Okay. So Jurgen, two more questions before we end today. So how do you how does building technology using data science, building things in systems analysis, how does that shape your sense of purpose and contribution to the world and others? And how does it actually help you make sense of the world?
That's a very big question,
Yeah, it's a loaded question.
I mean, look, let me give you some examples. Yeah, and then
Yeah.
let me go back to the healthcare space and some of the work that we're doing. Yeah. Um, so, like a simple example that even if somebody doesn't have a background in healthcare, yeah,
Mhm.
it's like when you get your cholesterol checked, yeah, which at my age I have to do annually, yeah, and basically, I mean, they measure your good cholesterol, your bad cholesterol, right? And I can look at is the good cholesterol within the range I'm interested in, is the bad one is in the range, but they also look at what's the ratio. Okay, and so now for the
Mhm.
ratio, it means now I actually need two variables at a time. So this is the turns from a univariate problem into multivariate problem.
Yeah.
Okay, and obviously now that's just for cholesterol, but when you start going to much more complex conditions where there is not this one measurement that tells you if you
Mhm.
have condition X or Y. You're looking for patterns. But now then this allows you can, for example, you can diagnose people earlier using data science than you could without.
Yeah.
Okay, at least it has the potential. Yeah,
Mhm.
and now if I can diagnose people earlier, that means I may be able to get them therapies earlier. If I really put on my science fiction hat, okay, maybe I can diagnose it so early that you're actually not suffering from the condition yet because it hasn't developed to the point, and maybe I can slow it down that you will never have to suffer from this
Mhm.
condition. That way,
Mhm.
I haven't. I mean, that way I wouldn't have cured anybody, but at the same time, I improved your quality of life dramatically. Now, that doesn't
Yeah.
work for autism, okay? Because
Yeah.
autism is developmental rather than degenerative. But
Mhm. Mhm.
here that you're basically using data science to find trends, yeah, and to which may lead you to saying, hey, let's run another measurement. Yeah, let's get another blood sample to measure something else to rule out certain other conditions.
Yep.
All of those things can really improve quality of life.
Life. Yeah. Yeah.
Okay.
Yeah.
And because what you find, I mean, if you ever look at anybody who has a complex medical condition and you find out, well, how many years does it take to diagnose this? And you find like the average time is super long. Okay.
Mhm.
That means these people had conditions already. They knew something was wrong, but nobody knew what was
What
wrong.
it was.
And,
Yeah.
and therefore, nothing couldn't be treated properly. Yeah. And if you basically can use AI to guide this process early on by saying, hey, there are certain trends here. This does not look normal.
Mhm.
It doesn't mean you should panic and worry about it and never reduce that quality of life. But basically saying like, look, there's this could be this, this, and this, and this, but there's a certain tests you can run to rule out some of these things, and we can get this diagnosed much earlier, and then you can do something about it. That really improves people's quality of life
Yeah.
significantly. Okay, I
Yeah.
mean, I know some of what I just said is science fiction, but some of this were not that far off.
Yeah. 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 Yeah.
And so this is where data science really has an impact that goes way beyond what we can do. I mean, at the second item related to this, I mean, when it ever comes to healthcare, there's always the quality of care and there's always a cost issue.
Mhm.
And when you want to give as many people as possible as high a quality as you can, but as you look at what things cost in terms of you can't ignore that. Okay,
Mhm.
that's one of the constraints you're running into.
Yeah.
And so if you can use data science in order to basically guide these things to basically to help with to help with earlier diagnosis, more accurate diagnosis, which can also then help with better or more accurate treatments.
Mhm.
You have a lot of potential there as well.
Yeah. Yeah, yeah. So yeah, last question, and this is usually like a fun question I've been asking people, and you alluded to it already with some science fiction. And as a science fiction author myself, I like playing around with these things. So if the entire world, so there are two scenarios, the entire world goes full dystopian, right? And what I mean full dystopian is, we build this technology that is not necessarily helping us, like we have these machines taking over our lives. We're kind of indebted to the technology. That's full dystopian. But on the other hand, is a utopian world where we have a long life. Where these intelligent systems that were built are actually serving us well. We're not stressed about work. We're not stressed about finances, right? Utopia, right? So we have these two scenarios. If you were to choose one, either one is fine. You could choose dystopian or you could choose utopian. Like, choose one and then tell me what practices you do on a daily basis just to, you know, nurture meaning in your life or just to stay sane.
Okay. I mean, look, well, I don't find the dystopian one interesting at all. Okay, so it's clearly not that. And obviously, the question becomes, how do you define utopian? And there, look, we when we can use data and automation to make our life simpler, I am all for it. Okay.
Mm-hmm.
Now, I don't want to push that to the degree where people become mindless because the machines take care of everything. I personally think that having both a proper job to go to, yeah, and interactions with other people, right? Not just computers,
Mm-hmm.
by the way. Yeah, and interactions with other people, I think that that's very healthy for human beings, and I
Yep.
think that should be. But you could argue that could be part of utopia, right?
Mm-hmm.
And so, but at the same time, there are certain types of labor. I mean, if your machines help you with it, I'm all for it. Okay,
Yep.
so if it can be automated.
Yep.
So I'm more on the utopian side, but I don't.
Mhm.
I'm not a believer in this that the machines will take care of everything that we don't want to do, and then we just have spare time at home because I
Yeah.
don't think that that's good for anybody either. I think
Mhm.
there's certain types of jobs maybe that maybe people don't need to do anymore, or where they're more supervising machines and computers rather than
Mhm.
doing the hard labor themselves. I think that's a good thing.
Yeah.
Um, Now, when you said, "Well, how does my role fit into this?" Like, are you asking
Mhm.
what I would want to be, or
Yeah. Or what would you do? Like, what would you do with your time? Yeah, and
well,
what would you be
actually,
doing?
I know this may sound silly, but I actually like what I'm doing right now,
Mhm.
and I think that even in a utopian society, I do people think people need an education. Yeah,
Mhm.
to be honest, one of the most fun parts of this job is actually to work with students. Okay,
Mhm.
and more importantly than not just to work with them, but you see what they make of whether their careers,
Yep.
and then look at this and saying, "You know what? Maybe I did a little bit, maybe I've provided a little bit of, yeah, of the background they needed for this." Yeah,
Mhm. Mhm.
so this is, by the way, that's why it's
Yeah.
a lot of fun to talk with you, and you've written 4 books already. By the way, I have written a lot less than 4 books, so, so you got me beat there.
Yeah.
No, it's fantastic to look back at this and what you've made, out of your life and your career and say, "Well, you know what? Maybe I played a nice small place."
Yeah.
And
Yep.
so, I think that even in a very futuristic society, there basically, there's a need for that, and I
Mhm.
still like that part.
Yeah. All right. Jurgen, thank you very much. And it is self-evident that, what you're doing has impact. Look at me, almost 20 years from, when we were sitting in the lab at Texas A&M together, and we're both advancing, still talking about very interesting topics. And thank you very much for your time. And I'm looking forward to incorporating some of these insights that you've provided into my next book. So to end this
Yeah, thanks for having me. So
for sure, for sure, for sure. Thank you very much.